Hello students, welcome in the chapter 7 integration. Students, today I continue our MN method related a linear with the quadratic form. Linear with the quadratic form I continue. Yes. Students, upper part linear 6x plus 7 and bottom is a quadratic. So I just assume that in the MN way. So students, here first of all we are expanded by this denominator. X square minus 5 and 4 9 and 5 4s are 20. So now assume, yes, suppose your numerator part is equal to m d dx of denominator plus m and define mn value. So 6x plus 7, here m, 2x minus 9, 20 is 0. So 6x plus 7, 2mx minus 9m. Now students, wait, these coefficients are equal. So 6 is equal to 2m and 7 is equal to minus 9m plus n. So here m become 3 and that will be n is equal to 9 3s are 27 plus 7, which is 34. It means this numerator is ready. 6x plus 7 is a what? 3 d dx of x square minus 20 plus 34. And that now students, I start actually my numericals. So integration I, 6x plus 7 by x square minus 9x plus 20. Now you can apply your numerator is a finally we prepared by this mn rule. So it is students 3 into d dx and plus 34 by as it is. Correct? Now I separate both. One time this division and last time this 34 divide. So one of the answer is 3 d dx upon root r separation, and another 34 is separate. With that, now you noted the formula already in last part. Function upper derivative with root function. To related this one, students, root and upper derivative, which is 2 times root of function. And here I derive last term. What is last term? Middle term square, 4 into first term, and this part I successfully put it in the solutions. So 3 with 2 times root, and that will be, you can arrange by the last term. What is the last term here? Yes, x square minus 9x 81 by 4 and minus 81 by 4 plus c1 to related disintegrations. So my answer is 6 plus 34. Now students, wait and just decide it. These are perfect square trinomial, and this 2 is also perfect square value. So it will be x minus 9 by 2, and here how much? 80 minus 81 means minus 1, means minus half the square, and that is your final answer, variable and constant. So 6 with the x square 9x plus 20. Now here under root variable minus constant. So log of variable plus under root c, and c1 plus c2 I just write down c here. Students, these are root x functions, and under root means you can write down this value. It means this x square minus 9x plus 20, and here students, your whole numerical is very easily ending. Now I continue Question number 20. Same principle apply in this 20 numericals also. So integrations. Question number 20, x plus 2 and upon 4x minus x square dx. So here students, same going. First of all, this numerator related, assume x plus 2 is equal to m d dx plus m, and this is your 4x minus x square. Now you can try derive derivative and find out mn value. So students, here x plus 2, it is 4 minus 2x plus n. So x plus 2 is equal to 4m minus 2mx plus n. Now this x and this x, I just compare it. So students, here coefficient just you compare, and another 2 is equal to 4m plus n. So what is the m? Minus half, and 2 is become half with minus. You can derive here minus 2, n become 4. It means your numerator is ready. X plus 2 minus half d dx of n is become 4. This value, now I operate in my integration solutions one by one, students. So your question is integration I, applying the fully solution now. Already you define your numerator value x plus 2, so your integration is x plus 2 below 4x minus x square dx, and that value is ready, minus half d dx with the 4, and that also same as. Now again repeat, it's the very easy funda, both are making separate. So minus half upon dx, and other is plus 4, these are same, dx. Now students, again noted formula, function with the derivative, lower side is root, it is 2 times root of x, and here getting x square negative coefficient, so it is your value for first term. So my first term is a middle term square, 4 into last term, it is 4x square, 16x square by minus 4, and that value is, students, you apply your first term value. So this answer is successfully we done 2 times root function, correct, and here 4 times, apply that your first term. You already defined there minus 4, so here 4 minus 4 C1. So your answer is finally minus 1 with 4x minus x square, and here I just derive, that is perfect square triangle. Yes students, these are 3 taking, and here are only 1 taking, so it is 2 square, and that will be x minus 2 the whole square, because already I take minus outside. So my answer is ready here, 4x minus x square. Now constant square minus variable square in the under root, so sine inverse formula apply after 3 are without root, 3 are with root, already I explained you. So it is a function by 2, and plus c. Here students, your this data is happily question number 20 done here. Now I go to question number 21. This also, students, in the same numericals wise going. Now 21 running. Integrations of x plus 2 with the x square plus 2x plus 3. Yes, here also, students, one of the linear and one of the our quadratic. So assumption same. Suppose your numerator related m ddx plus n. Always you apply the m in where? If you quadratic below given and numerator are variable to 1 power d, means linear given. So x plus 2, here 2x plus 2. So you getting here exactly 2mx, 2m plus n. Now these x coefficients and x coefficients are compared. So my value is constant with constant. So what is your m? Become half, and that will be also same, half, 2 to cancel. So n become only 1, and now both value you can apply in the your numerator. X plus 2 is equal to half ddx plus n become 1, and here, students, you stop, and after that you just put it m half and n 1. Now go to integration started. Yes, my integration is, students, x plus 2 same, and upon under root your value is applied in the same way. So numerator already I written there, x plus 2 upon under root x square 2x 3. That value already known you. So half with ddx and n become 1, and upon as it is. Now, students, you can try separations. One this separate, one that separate. So half with ddx of 2x plus 3 upon under root, and another are 1 upon same as. Now you know the formula again. Function root with the derivative. So integration function derivative by root fx 2 times fx, and here getting last term. Yes, students, last term, middle term square 4 into first term, it will be 1. So my answer is ready here. In this way again, 2 times root of function. And here, students, I just rearrange by last term. So x square plus 2x plus 1 plus 2, because I want total 3. These are perfect square, and here making I in the perfect square term 1 plus 2. So my data is a under root x square 2x plus 3, and here it is a perfect square trinomial x plus 1 whole square, and it is root 2 square. Now answer is coming. Yes, under root with the function square plus variable square. So my data is exactly correct. Log of function, correct? No, variable plus under root, and c1 plus c2 I mentioned c, variable x plus 1, and in the root you can write down again your question x square plus 2x plus 3. and here students you easily going to 21. Done. Now students I apply to 22. Same is and the same pattern. I hope you understood this method very well in these solutions. Now students, continue question number 22. Integration of x plus 3 with the x square minus 2x minus 5. Yes, x square minus 2x minus 5. Same applications. Here our one of the quadratic and that is a linear. So suppose x plus 3 is equal to m ddx plus n. Derive mn value. So students, here x plus 3, it is 2x minus 2, 0 plus n. So you just getting 2mx minus 2m plus n. Compare the like term related to your coefficient of x. So here 1 2m, and secondly, so what is the m? Become half, and it should be same as minus 1. Students, you getting here n is equal to 4, and both value successfully apply in your questions. So here students, your numerator is ready. X plus 3 is equal to m become half ddx and n is a 4. That value now I systematically apply in the solutions, and you getting easily students answer here. So after that find out mn value, you can start. Finally I, and your I is ready. That students, integration of x plus 3, x square minus 2x minus 5 dx, and that x plus 3 is this one, half with the ddx, and n become 4 upon same as. Now you can make again two separations, half with the ddx upon denominator, and secondly students 4 with the dx. Again you go to legal formula. Already we know that function upper side derivative. So what you get answer? Log of function. And here create your successfully last term. So middle term square 4 into first term, it gets only 1. So students, my answer is ready, log of function. And here answer is become converting into last term, x square minus 2x plus 1. I want to minus 5. So can we write here minus 6? Yes, 1 minus 6, it will be minus 5. So my data is ready, half log, and here 4 times, it is perfect square. Now time coming to formula. Without root, variable square minus constant square, it means 1 by 2a log. So your answer is students here successfully done, 1 by 2a log with the plus c. And students, your variable first, so upper side minus and downside plus. A become root 6, 2 2s are cancel, and that's your students. Here also is very easily and happily done here students. These are 20 2 number. Now students, after ending this, I continue our question number 23. Also same concept in the method of same. My question is integration of 5x plus 3 with the x square plus 4x plus 10. 5x plus 3, x square, 4x and 10. So students, same operating again. Assume numerator is the m d dx of denominator plus n and derive mn value. You can make first derivative. So 2x plus 4 is 0. So 5x plus 3, 2mx, 4m plus n. So these are just coefficient value. Compare. So 5 is equal to 2m and you derive m value 5 by 2. And secondly students, coefficient compare. 3 is equal to now constant compare. M become 5 by 2. 2 2s are cancelled. So your answer is 10. N become minus 7. It means your numerator is done 5x plus 3 with the 5 by 2 ddx of n is a 7, and that you utilizations in your further solutions for the n related students. So I continue in my solutions for one by one. So your eye is ready for integration of 5x plus 3 upon x square plus 4x plus 10. Now students, easily we going ahead. These are numerator already done, and apply that 5 by 2 ddx of, and what is the n? Minus 7, and upon as it is x square 4x plus 10. Now both separations. One of the 5 by 2 ddx, this whole data by under root, and secondly this minus 7 with the upon under root. This is the same data. Now you know the already very well formula, function root by derivative. This one, function by under root, sorry, only fx dx to related this one. So my answer is 2 times root fx plus c, and here go to last term, empty square, 4 into x square, it will be 4, 16x square by 4x square. So my data is ready, 2 times root, and here minus 7 with the, you can arrange in the last term. Last term is a 4. So x square, 4x, 4. But I want to 10. So plus 6. And plus c1 is the integration, 2 to gone. X square, 4x, 10. And here students, you can apply. These are perfect square trinomial. X plus 2 and 6 is known root 6 square. Now final destination coming to in this part, root forming variable square plus constant square. So you know the formula students, it is log of variable plus constant. This means your variable plus your root. In the variable you can apply x plus 2, and the root are this full write down. It means you write down question x square plus 4x plus 10, and here students your 23 is done. Now I go to continue our 24th question. Same is these all are the same related numericals, students, in the MN method. Now 24 is a one kind of MCQ. Integration of dx x square plus 2x plus 2. Very easy. I just operate now last term. Here only given quadratic, not given linear. So last term is a midterm square. 4 into first term. It is 4x square by 4x square. It is 1 only. So you can write down here 1 plus 1. These are perfect square trinomial. It getting perfect square. And 1 square, you know. Now formula. Variable square plus constant square without root. 1 by a tan inverse x by a. So your data is finally done. Tan inverse x plus 1, and that is, students, your example question number 24 is easily done. Now continue 25. That also one of the our MCQ. Only two little MCQ given in your book. So question 25, integrations dx by in the under root 9x minus 4x square. Yes, students, here x square coefficient negative given and only quadratic. So I go to last term. Yes, correct thinking you. Last term midterm square 4 into first term. So my middle term is a 9x square and 4 minus 4x square. Students, here my mistake that first term find out because x square negative, here write down last term. Now correct, midterm 9x square, 4 into last term is a minus 4x square. So my answer is a 81, 4 for the 16 but minus. So you can derive the solution. Your 81 by 16 extra added and subtracted, and other are same is these three are perfect square trinomial, and it is a making perfect square. So dx by it is 9 by 4 whole square, and here just minus common 4x square minus 9x 18 by 16. So your answer is finally, students, derive in the perfect square trinomial. It is which term perfect square? Yes, 2x minus 9 by 4. Now constant square minus variable square. It is sine inverse and coefficient of x is a 2. So your data is 2 half sine inverse plus c. And in the sine inverse, students, variable upon a. Now take the LCM, half sine inverse. It will be 8x minus 9 by 9 plus c. 4 to the 8 minus 9 and LCM, students, cancel. And now here, students, our this exercise 7.4 is done. Now I after that start very easily new topic is a partial fraction, and here, students, I ending this topic. Now students, after ending our MN method, I start the little topic integration by partial fractions. Yes, partial fractions means making by parts. In their parts, total 5 different criteria. So first of all, variable px plus q, it means single power, linear by quadratic in the 2 factorizations. If you 2 factorizations given, then you can take here 2 different constant, and both of you separate x minus a, x minus. This is your by parts. This is the parts I taking. Same as, students, I going here third one. There are 3 parts, so you can take a, b, c, and anyone you apply the down value, x minus a, b, c, As you like, here C, here A, here B, it is true. So first and third are same. Now second and fourth is also same. Look at that. There are two factors, but both repeat. If you repeat, then also taking the two constant. One time x minus a, other are x minus a whole square. Either here whole square, here single, as you prefer. In your textbook given here square, it is true. Same here students, check. There are three, two here and one. You can take three constant. One of the repeat portion, x minus a and x minus a whole square, and other are x minus b. And the last, it is a very most IMP topic. Factor with single constant, but here your quadratic data. And whenever you quadratic, you can apply a linear constant, bx plus c. B and C are constant and x is linear. And here students, this is a five method you can utilize in this by the method of partial fractions. Yes students, now I check little sums. Example 11. Integration of dx below x plus 1, x plus 2. Yes students, here there is a two different factors, so I operate the first method. If you 3 given, then third method. So by partial fraction method, you can try two partition. One of the A partition, another are B, and you can write down in the x plus 1 and x plus 2. Very easy and be derived. So you take the LCM. You have to A with the x plus 2, B with the x plus 1 upon same is. Now LCM is cancelled. Other are derived in constant. So 1 is equal to ax, 2a, bx, b. Can we write down here 0x plus 1? Because x is coefficient 0 here. And already here a plus bx and 2a plus b. These are common taking in our comparison. First comparison, a plus b 0. Second, 2a plus b is equal to 1. And make your solutions. This cancel. Minus a minus 1. A become 1. So what is the b become? A1 apply. B is minus 1. It means students, your partial fraction is ready. And now your integration start. This already you derive a with the b, correct, in the place of this. Now happily putting a value and b value. So my a value is a 1 upon x plus 1, b is a minus, and integration is ready. Then log of x plus 1, log of x plus 2, base e. And here students, only one step for integration is done. Now minus property, you know the log indirectly. X plus 1 by x plus 2 plus c. And here students, this first property related to one little example here happily done. Yes students, now I stop this topic. I mean stop this part, not topic. This part is stop here students, and further explanations I explain you in the next part. Okay, bye bye.